Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the isometric projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the orthographic views of the solid, wherein the front view, the top view and the left hand side view of the solid, they have been provided to us, and using the information available through these three orthographic views, we are required to draw the isometric projections of the solid. And we already know that in the isometric projections, all these three faces, that is the front face, the top face and the left hand side face, so all these three faces will be clubbed into a single 3D isometric projection. So in order to draw the isometric projections, we need to evaluate the dimensions of these three faces. So let us evaluate the dimensions of the front face. So in the front view, we are able to observe that the length of the solid happens to be 90 millimeter, whereas the height of the solid, it is also equal to 90 millimeter. So the front view face in the isometric projections will be having the dimensions 90 millimeter by 90 millimeter. So whereas the top face, it will have the length equal to 90 millimeter, while the width of the top face will be equal to 70 millimeter. So this information we are going to get from the left hand side view. So the dimensions of the top face in the isometric projections will be 90 millimeter by 70 millimeter, whereas the side face in the isometric projections will be having the dimension width equal to 70 millimeter and the height, it is equal to 90 millimeter over there. So the side face dimensions will be 70 millimeter by 90 millimeter. Now since in this isometric construction we have been provided with the left side view of the solid, so in order to draw the isometric construction, we know that since we have got the dimensions regarding the left hand side view, so the left hand side view will be drawn along the XY plane over there. So this is the x-axis in the isometric projections, this is the z-axis in the isometric projections, and this is the y-axis in the isometric projections over there. So in between, so within this XY plane, we have to draw the left hand side view face over there, whereas the front view face of this isometric construction will be drawn in the YZ plane. So this is the y-axis and this is the z-axis, right? And accordingly the top face of the solid will be constructed over there. Now let us work out this particular geometric construction. So in this geometric construction, we have got three steps over there which are having the dimensions. You can check the height over here corresponding to these three steps, it is equal to 30 millimeter, whereas the length, so length over here, it is also equal to 30 millimeter. For the second step, the length is again 30 millimeter, while the length of the third step, it is also equal to 30 millimeter once again. So we are going to get, please check, if we are going to look at the solid from the top, so we evaluate that there is an L-shaped web over here which happens to be a flatter web. So this is L-shaped web which is lying at the top surface of the solid. And what are the dimensions of this particular L-shaped web? This dimension, it is equal to 30 millimeter, and this is the length. So this length of the top web, it is equal to 30 millimeter, and this is the width of the web. So as it is turning towards the left side, so this width of the web, it also happens to be 30 millimeter. This information is available to us through the left side view. So this is the 30 millimeter width of this web over here. And another thing, as this web is turning towards the left, so towards left, this length of this upper face will be equal to 45 millimeter, and then this web, it will be moving down inclined towards the bottom step over here, that is towards the top of the step 1. So this web, which is having a thickness of 30 millimeter over here, that is the width equal to 30 millimeter, it will be moving down from this point, which is at a distance of 45 millimeter from the rear back side face of this particular solid. So you move 45 millimeters towards the front face. So this is the front face of the solid, and then this web, which happens to be 30 millimeter thick or 30 millimeter wide, it will be moving down to this point, which is the top point of the step number 3 over here. And then there are 3 steps as we have discussed. So these 3 steps, they will be having the width equal to 40 millimeter. So if we just translate all these dimensions over there, we can check this is the width of the inclined web, right? So this is the inclined web that we are having. So in the side view, this inclined web will be shown over here. Okay, so this is the apparent shape of the web, which is inclined, and the inclination is observed from the front view as it is seen in the front view of the orthographic projection. And the width of these 3 steps, it is equal to 40 millimeter. And these 3 steps, they are going to have the dimensions, that is height, which is equal to 30 millimeter, and this length of these 3 steps, this will also be equal to 30 millimeter. So with this basic discussion regarding the geometry of the object, now we are going to start with the construction of the isometric projections of the solid. And as we already know, the front view will be constructed along the YZ plane in the isometric axis, and the left side view will be developed along the XY isometric plane in the isometric projection. So in order to draw the isometric projection, so first thing we need to construct the isometric scale, in which the true length will be drawn at an angle of 45 degrees. So this will be the true length scale, and we are going to mark different dimensions over here, and then we will be drawing the perpendicular projections from the true length scale onto the isometric scale. And this isometric scale we have constructed at an angle of 30 degree. So whenever we draw the perpendicular projections from the true length scale onto the isometric scale, so we get the conversion of the true length dimensions into the isometric length dimensions over there. So all the dimensions which are given to us in the orthographic views, so they will be first of all converted into the isometric dimensions, and only the isometric dimensions will be used to construct the isometric projections of this particular solid. Now let us draw the isometric projections. So here we have the isometric axis, which is equal to the x-axis. So this axis is again the isometric axis, which is the z-axis, and both the x-axis and the z-axis, they will be constructed at angles of 30 degree from the ground point. So this is the ground point. So first thing what we have done, we have constructed a horizontal ground line and marked the starting or the origin point over here. So this is the origin point. So from the origin point, we have drawn the x-axis towards left side at an angle of 30 degree, and from this ground point we have drawn the z-axis at an angle of 30 degree towards right, and the y-axis will be perpendicular to the ground, and this will be drawn perpendicular to the ground axis, and this is going to represent the height of the solid over there. Now let us start with the construction of the front face. So here, as we have discussed, that we are going to draw front face of the solid along the YZ plane over here. So this is my y-axis, this is my z-axis over here. So I know that the length of the solid in the front face, it is going to be 90 millimeter. So I have marked length dimension along the z-axis as 90 millimeter, and the height of the solid, it is also equal to 90 millimeter. So I get the construction of a square face towards the right hand side over here. So this is the square face which I have constructed on the right hand side, that is between the YZ plane. So I have marked this face of the isometric construction as front view over here. Now let us start with the left side view. So in the left side view, we know that the dimensions of the left side face will be 70 millimeter by 90 millimeter. So this is the left side view, which is having the width equal to 70 millimeter and the height, it is equal to 90 millimeter in the left side face. So let us draw this particular dimension of 70 millimeter along the x-axis. So please check, I have marked this dimension along the x-axis, which is equal to the width of the solid. It is equal to 70 millimeter. Now having drawn this width and the height, now I am going to complete the left hand side face. So this is the isometric line which I have drawn parallel to the x-axis. This is again the isometric line which has been drawn parallel to the y-axis. Now let me complete the top face of the solid. So I know the dimensions of the top face. The dimensions of the top face will be length, it is equal to 90 millimeter. I can check it over here. Length, it is equal to 90 millimeter, and the width of the solid happens to be 70 millimeter over here. This is the width of the solid, which is 70 millimeter. So this is the width equal to 70, and this is the length, it is equal to 90 millimeter. So the top face has also been obtained over here. Now I have to complete the bottom face of the solid. In order to complete the bottom face, again another isometric line which will be parallel to y-axis will be drawn, having height is equal to 90 millimeter, and similarly another isometric line which will be parallel to the z-axis will be constructed, having dimension equal to 90. And finally the last isometric line, another isometric line will be constructed which will be parallel to the x-axis, having dimension equal to 70 millimeter. So with this, we have been able to obtain a rectangular prism which is going to contain all these three faces of the solid. The left hand side face 70 millimeter by 90 millimeter. The front face, it is a square 90 millimeter by 90 millimeter, and this is the top face which is having the dimensions 90 millimeter by 70 millimeter over here. So after this construction is completed, I know that there are three steps. Please see, here you have first step, it is at a height of 30 millimeter from the base. Then there is another step which is having another 30 meter height over here, right? So these two steps, they are at height of 30 millimeter each from the base. So what I am going to do, I am going to draw a ring over here which is drawn at a height of 30 millimeter from the ground. So this is going to give me the construction of the first step of this particular solid over here. So I have drawn a ring over here which is again nothing but a reference line or a guidance line to me. So along this guidance line or the guidance ring over here, I will be obtaining the step number 1, which is lying over here at a height of 30 millimeter, and this length I will be obtaining over here. Similarly, the second step will be again at a height of 30 millimeter from the top surface of step number 1. So another ring now I am going to construct over here, for which the height above the first ring will be 30 millimeter. So two rings I have been able to construct which will facilitate me to obtain the step number 1 and step number 2 of this geometric construction over there. Then we also discussed that at the top, please check, at the top we have got this L-shaped surface which is a flat surface over here. So how did we determine that this is a flat surface? Because the front view for this surface, it is a flatter one. It is giving us a flat construction over here. So that is how we determine that this is a flat construction. Now since we are going to look at the solid from the front view over here, so we are going to draw a line or a projection line which will be 30 millimeter from the right hand face of this particular solid. So this is the right hand face of the solid. So this will be my right hand face of this particular solid. So what I am going to do, I am going to mark this distance. Please check. I am going to mark this distance equal to 30 millimeter from the right hand side face of this particular solid. So once I mark this guidance line, that is, I am going to mark a projection line over here which will give me information about the width of this web. But I further find out that this web is not going straight. So this web is turning towards side as I am moving towards the rear face of the solid. This is the rear face of the solid. So please check. This is my rear face of the solid. So as I am approaching the rear face of the solid, again this width of this web will be same. It is equal to 30 millimeter. From where I have obtained this width equal to 30 millimeter, this width of 30 millimeter is available to me in the side view over here. So in the side view, I have obtained this width of the web equal to 30 millimeter. So what I am going to do, I am going to mark this width from the rear face of the solid. This is the rear face of the solid. So from the rear face, again 30 millimeter width I am going to mark over there. The moment I mark this width equal to 30 millimeter, another construction line I am going to draw on the top face which will be parallel to the z-axis over here. So this isometric line, it is parallel to the z-axis. Now this web which is turning towards the left side over here, but it is not reaching this last point over here. So as this web turns towards the left side, we see that from the top view. So this information is available to us in the top view that after a length of 45 millimeters, please check, the length of the straight portion happens to be 45 millimeter. So after this 45 millimeter of the straight cross section, now this web will be moving down up to the top portion of the step number 1 over here. So there will be inclination of this web up to the top surface of the step number 1. So what I have to do, I have to obtain this 45 millimeter straight cross section of this particular web as it turns towards the left, towards the rear end. So please check, this is my web which is moving from the front face to the rear face, and on the rear face side, now I need to measure this distance equal to 45 millimeter. So I have marked this distance equal to 45 millimeter. The moment I mark this distance, now another isometric line will be constructed which will be parallel to the x-axis over here. So this is my x-axis. So this isometric line will be drawn on this top web. So now I can see that this is a web which is an angled web over here, and it turns towards the left side on the top face. So this gives me the construction of the top angled web over here, right? So this is the construction. Now having obtained this construction of the web, now I have to go for construction of this inclined section of the same web. Now this web is having the thickness equal to 30 millimeter. Where did I get this thickness? I am getting this thickness from the top view. So this is the top view, or even in the left side view. The thickness of the web, or I can say that the width of this particular web, it is equal to 30 millimeter. Now from this point and this point, I need to draw the non-isometric lines which will be joining this point with this point over here, and then another parallel non-isometric line I will be drawing at a gap of 30 millimeter from this point, because of the uniform thickness of this web. This is equal to 30 millimeter. So the first non-isometric line I have drawn, please check, from this corner to the top face of the step number 1. So this is the top face of the step number 1. So starting from this point, which is this corner, which is lying 45 millimeter from the right side towards the left side, right? So from right side corner towards the left side as you move along 45 millimeter. Then this web will be moving down as an inclined surface over there. So one edge of this inclined web I have been able to obtain. So another thing I can do, I can mark another 30 millimeter distance over here and then join this point with this point. Or the second thing I can do, I can draw an edge which will be parallel to this non-isometric edge, and starting from here I will be drawing this edge which will be joining the top surface of this particular step number 1 over here. So this way I have been able to obtain this flat web over here at the top and this inclined web over here on the rear side of the solid. Now in the front side we have already got 40 millimeter area or the space left with us. So the total, you can check, the width of the solid happened to be 70 millimeter, out of which 30 millimeter was there corresponding to this inclined web over here. So 30 millimeter width we have already drawn. Now we are left with 40 millimeter width of this particular solid, which is this one. We can see total is 70 millimeter. 30 millimeter we have already used to construct the web, and the remainder width of the solid happens to be 40 millimeter. Now what I have to do, this is my step number 3 at the top. So the flat surface of the step number 3, it is having the length. Now this total length is equal to 90 millimeter, which I am required to divide this into 3 parts. So first part, please check from the front view. This is 30 millimeter. This top face I have already drawn. Now I need to move downwards with a height of 30 millimeter over here. So this is my height, or I can say this is the depth of the step number 1. This is equal to 30 millimeter. So from this, please check, from this portion of the solid, which happens to be having 40 millimeter of the width, now I am going to draw the vertical projections which is having the dimension or the depth equal to 30 millimeter. So the height of the step number 3, it is equal to 30 millimeter. So this is 30, height of the step will be equal to 30 millimeter. So one vertical projector I have drawn over here, another vertical projector I have drawn over here. So I have obtained the 2 faces of this vertical web, and now this horizontal face, this horizontal edge I need to evaluate. So in order to draw the horizontal edge, I have drawn, please check, this horizontal edge over here. Now having reached this point, now the second step needs to be drawn. So in order to draw the second step, I need to move forward further by 30 millimeter distance over here, because the length of the second step happens to be 30 millimeter once again. So this is the length of step number 2. So what I am going to do from this point as well as this point, so these were the 2 points which I had obtained in order to reach at this particular corner over here. So after I have reached this vertical corner, now I will be moving forward. Moving forward means moving towards the left hand side by a distance of 30 millimeter. So from here I will be measuring again 30 millimeter distance. This distance happens to be 30 millimeter, and again this distance will also be 30 millimeter. So please check, I have marked this distance equal to 30 millimeter, which is the length of step number 2 over here. So having reached this point, so this corner needs to be obtained. So in order to obtain this corner, I will be joining this point with this point over here. So this flat portion of the second web or the second step, it has been obtained over here. So this is the flat portion of the second step which has been obtained. Now I have reached this portion. Now from here I need to move another 30 millimeter downwards. So this is the downward distance, that is the height of the second step is also equal to 30 millimeter. So from these 2 points, this point and this point, I will be moving down by another 30 millimeter. So how do I decide I have moved 30 millimeter? Because the distance between this ring and this ring is also 30. So this 30 millimeter I have moved down, so that I have been able to reach at this particular point. So once I reach this point, so one vertical projector from here 30 millimeter downwards, and another vertical projector from here 30 millimeter downwards I have obtained, and this distance between the two rings I have already marked equal to 30 millimeter. So this is equal to 30 millimeter. Now this vertical portion of the second step has also been derived. I have been able to reach this point starting from this point. So once I reach this point, now I need to move further towards the left hand side portion of the solid by another 30 millimeter. So from here I will be drawing two projection lines which will be having the length equal to 30 millimeter. That is in the first step. So this is my step number 1. Again the length it is equal to 30 millimeter. So once I reach this point, now this corner needs to be obtained. So it is this corner which I am talking about. In the top view, this edge or the corner will be appearing as an edge view over here. So once I obtain this, so step number 1 has been obtained, step number 2 has been obtained, and step number 3 has been obtained. So we have been able to obtain all the edges or all the strips corresponding to the isometric projections. Now we are going to darken the edges in the isometric projection as they will be visible to the observer from the front view, from the left hand side view, and from the top view. So we can check over here if we are going to look at the solid from the left side. So this is the rectangular section we were able to see in the left side view. We can check it. We can side by side correlate between this isometric projection and the orthographic projections over here. So in the orthographic projections, we had a rectangular face from the left hand side. Then from the top also, you please check, as I discussed earlier with you, that this is the L shape of the top surface over here. So this is the top surface width which is moving first of all straight and then it is turning towards the left side. So please check, this is web which is flat and it is lying at the top surface having length is equal to 30 millimeter, and over here again the width will be also equal to 30 millimeter. So this is the length 30 millimeter and the width it is also equal to 30 millimeter. So this is the L-shaped web over here. So this we have been able to obtain, and then these are the slant edges corresponding to the inclined surface. So this slant we are able to see over here. In the front view, this is the slant web which we are able to get, and in the side view also we can check, this is the rectangular surface which is the apparent view of this inclined web. This inclined web is having bigger size, while in the orthographic projections this larger surface of the web appears to be an apparent shape in the left hand side view. Now let us complete the 3 steps over there. So this is step number 3. So in the step number 3 we have to move down by 30 millimeter, and this is the 40 millimeter length of this step. Again step number 2, the length is again equal to 30 millimeter, and this corner I need to obtain. So this corner is corresponding to this surface in the top view. So this is the surface in the top view which will be appearing as a corner over here. So this corner I have been able to obtain, and then this is my vertical section of the step number 2, and this is the horizontal section of the step number 1. And we can check over here, there is a small gap between this point and the surface over here, and this is also coming out to be the same gap in the front view of the orthographic construction that we had obtained. So this is the complete construction of the isometric projections of the solid when the orthographic views of the solid, that is the front view, the top view, and the left hand side view of the solid, they were provided to us, right? So this is all for today. So we'll be continuing with the discussion regarding few more cases on the isometric projections in the coming lectures. So thanks a lot. Thank you very much.